Hi, 4th grade, it's Mrs. Boswell. Today we're going to do Module 5, Lesson 27, and we're going to do more comparing of fractions greater than 1. We're going to compare fractions greater than 1 using models. Remember, you can pause and stop at any time that you need throughout the lesson. This is going to be on page 67 and 68 for me. So again, this is Module 5, Lesson 27, Comparing Fractions Greater than 1, just like we did on Lesson 26. But today we're going to, when we did Lesson 26, we did number lines. Today we're going to use different models and number lines. Alright, so here we go. Let me line it up for you so it shows up a little better for you. Alright, so it says comparing fractions greater than 1 using models. It says I can compare fractions greater than 1 by reasoning. Okay, so I'm going to think it through. Benchmark fractions by creating common numerators or denominators. Okay, so yesterday we focused on the whole unit. Okay, today we're going to do more focusing on the unit, but looking at common denominators and common numerators. Okay, but we're also going to be using tape diagrams or even number lines. So here we go. My first two numbers, and I'm sorry, I feel like that's really blurry, is 3 3/8. And I'm going to compare it to 3 3/4. Okay, so I need to figure out who is bigger. Okay, so I want to look at it first. Okay, and I could look at the denominator, or I could also look at the numerator. Okay, and I notice that the denominator is 8 in this number, and the denominator in this mixed fraction is 4. Okay. Okay, I'm so sorry, let me see. It says, can you compare another weighted fractions? It says we can use denominators. Okay, it says 4 is a factor of 8. We can convert fourths to eighths by decomposing each fourth to make eighths. Okay, we can draw a tape diagram to do that. Okay, so here's the thing I want to look at. When I look at this mixed number, I notice that, guess what numbers are the same? That whole number is the same. So I'm not going to look at that. What I'm really going to focus on, 4th grade, are these fractions. Because if I had a number line and it was 3, right, or 3 to 4, I know that both of these are going to fall between 3 and 4 because they both have that same whole number of 3. So now I have to focus on that fraction. Okay, so if I'm focusing on that fraction, we're going to look at that denominator. So I have 8 and 4. Okay, and I'm going to draw a tape diagram to represent both of those numbers, or to kind of show me an equivalent fraction for it. So I have 3/8 and 3/4. So if I draw this up here, I'm going to draw 3/4, right? So I've got 3, or actually I should have 4. So 1, 2, 3, 4, correct? So there's my 3/4. And I would color in how many of them? 3. 1, 2, 3. Right? Well, then if I were to take this one, and I want to represent 3/8, so I'm going to do this one. Right? 1, 2, 3, 4, 5, 6, 7, 8. There's 8s, right? And I'd color in 3. 1, 2, 3. So there's my 3/8. Okay. Now, I noticed that when I drew this tape diagram, it's a little bit bigger than this tape diagram. So that really, if I'm looking at the tape diagram, doesn't quite help me. But I could do this. I know that when I look at that denominator, the common factor between 4 and 8 is 8. So I'm going to take this one up here, right? and I'm going to end up with 8. So 4 times what is going to give me 8, right? And then whatever I do at the bottom, I have to do at the top. So 4 times 2 would give me 8, right? So 3 times 2 would give me 6. So I would have 6 eighths. Okay. Well, what does that mean I have to do to each of these units, right? I multiplied it by 2, so that means I have to divide it into 2. So I'm going to divide this one into 2, this one into 2, this one into 2, and this one into 2. I'll make that a little bit longer so you can kind of see that, right? So now how many parts do I have? I should have how many parts? 8. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8, right? And then I should have 6 colored in. Let's count. 1, 2, 3, 4, 5, 6. So 4th grade, now I can really look at this, and what I'm comparing is 3 eighths to 6 eighths. Well, does that mean when I compare, we're going to think about greater than, less than, or equal to? Well, equal to means they would have to be the same. They would have to be 3 eighths and 3 eighths. Are they the same? No. So it's not equal to. Okay. So I know now that my denominator is the same, I'm just going to look at that numerator. Which is greater, 3 or 6? If you said 6, you're correct. That 6 is greater than 3. So 3 eighths is less than 6 eighths. So now that I found that common denominator, I can come back down here, back to my original units, right? 3 and 3 eighths is what to 3 and 3 fourths? Well, we decided, right? So that 3 fourths became 6 eighths, so I know that it is greater than the 3 and 3 eighths. So 3 and 3 eighths is smaller than 3 and 3 fourths when we compare those two. And this time I used a tape diagram. Okay, let's come over here and let's do 4 and 1/3 and compare it to 4 and 2/9. Okay, remember we're going to find out if it's greater than, less than, or equal to. So let's look at our first part of our mixed fraction. I noticed that both of them have 4, so I don't have to focus on that. So now I'm going to look just at the fraction piece. 1 and 1/3 and 2/9. Okay, now I did a tape diagram over here, right? Over here, I'm going to use a number line. Okay, and I'm just going to put it there. But I'm not going to put anything on the number line quite yet because I want to look at my fractions. Okay, now let's look at our fractions. I have 1/3 and I have 2/9. Okay, I want to see, are there any common factors between 3 and 9? If you said 9, you're correct. Their common factor is 9. Okay, so I can take that 1/3 and get it to equal 9ths, right? So what times what, right? I could do it that way. So 3 times 3, right, would give me 9. So then up here I would have to do 3. 1 times 3 is 3, so I'd have 3/9. So this would be 3/9 and then 2/9, right? Well, if I didn't want to do it this way, I could have used my number line. The first way I would have done it first, okay, is I would have divided it into thirds, right? So I'd have 0/3, 3/3, 1/3, 2/3. So there's my thirds, right? Pretty easy. I can put those on there. Why did I put 3/3 here? Because that means that's my whole. Okay, I would have a third here, right? Now, I'm going to have to take this line and now I'm going to have to divide it into 9ths. So I'm going to come up here. I'm going to have 0/9. 9/9 would make a whole, correct? Okay. Let's see. I would go kind of like thinking halfway would probably, it doesn't go quite way, like 9ths don't really go in halves, so it makes it a little harder. So I'm just going to try and do my best. So I'm going to go, and I noticed that my 9ths are going to have to be, because I'm going to have a lot more. Thirds was easy because I could spread them out, right? But 9ths have to be a little bit closer. So I'm going to go 1/9, 2/9, 3/9, 4/9, 5/9, 6/9, 7/9, 8/9. Ooh, look how closely those are really spaced together, right? Because it's smaller pieces. So let's do this. My first one was 1/3. So here's 1/3, right? Here's 1/3. Okay. Where's 2/9? Ooh, here it is. It's right here. There's 2/9. They're pretty close, right? But who's greater? Is 1/3 greater or 2/9? Well, again, if I come down here, I know that 3/9 and 2/9, there's that common denominator, right? 3 is greater, so then I don't have to look at the denominator, I can look at the numerator. 3 is greater than 2. So I am saying that 4 1/3 is greater than 2/9. Because if I look at that number line, that third is bigger than the 9th. Okay, so again, I'm finding that common denominator. I can either use a tape diagram or a number line, it's up to you, or I can also use a strategy of multiplying it to find the common denominator. So remember, there are multiple different strategies to do this, okay? Let's go ahead and compare these two numbers, 5 1/4, 5 3/8, right? What if I would have said, I would have changed this 5 to a 4, right? If I had a 5 there, right? If I had 4 1/4 and 5 3/8, what do I already know is bigger? If I just looked at those whole numbers, I already know that 5 would be greater, right? So that's pretty easy, but it's not that. My 5s are exactly the same. So what I want to do, since my whole number is the same, I'm going to look at the fraction that goes behind it. So we're going to do that again. Okay, so I have 1/4 and I have 3/8. I'm going to look at those denominators. I've got 4 and I have 8, right? This time, I'm just going to use the sentences up here. I know that 1/4, okay, and 3/8, the common denominator, okay, is 8, okay? So I know I'm going to make this one an 8th. Do I have to do anything with this one? No, because it's already an 8, so I already know that's 3/8. So I'm going to do what? 4 times what gives me 8? 2, so whatever I do at the bottom, I have to do at the top. 1 times 2 is 2. Oh, 2/8. So I have 2/8 compared to 3/8. Well, which one is greater, or are they equal? If you said that 3/8 is greater than 2/8, you're right. 2/8 is smaller than 3/8. So down here, which is smaller? I'm going to go back. The original number was 1/4 and came to 2/8. I know that 2/8 is smaller than 3/8. So 5 1/4 is smaller than 5 3/8. Okay? So again, I'm using different models. I used a tape diagram. I've used a number line. In this one, I multiplied to find that common factor. Okay? You are going to decide which of these strategies works best for you. We're going to keep going. I'll go on to page 2. Okay? So this time, oh man, they have mixed fractions and fractions. Whew. So we're going to have to kind of figure these out today. And this is kind of what you were focusing on the other day, right? This is pretty easy because it already tells me it's 4 3/4. But this is not the same, 23/5, right? That 23 is bigger than 5. So I want to think about how many times can that 5 go in, right? So this one, I'm going to put this into a mixed fraction so that I can compare them, okay? It's easier to compare when you have a similar thing. This is a mixed fraction, this is just a fraction. But I'm going to make this one into a mixed fraction because that numerator is bigger than my denominator. So I'm looking at that unrelated numerators and denominators, okay? So I'm going to go 5/5, right? So I'm going to go 5/5, 5/5. So there's 5, 10, 15, 20. Oh, 5, 10, 15, 20. And then 20, I can't go any more because if I did 5 more, that would be 25. So I would have to do 3/5 is what's left over, right? I would add all those up. How many wholes do I have? 1, 2, 3, 4. Ooh, 4. So 4 3/5, okay? 4 3/5 is my mixed fraction. Now, 4th grade, can I compare these mixed fractions now? Yeah, absolutely. I noticed that their whole number is both 4. So I can move on to, now I can move on to the fraction itself. 3/4 and 3/5, okay? Well, I'm going to come up here and I can do tape diagrams again. I'm going to do 3/4, 1, 2, 3, 4, right? 1, 2, 3, 4, and I'm going to color in 3/4. 1, 2, 3. So there's 3/4, right? Now, I also have 3/5. 1, 2, 3, 4, 5, right? And I get a color in 3. 1, 2, 3. Okay. Which is bigger? I still feel like that can be pretty tricky. So what I'm going to do is I know that the common number between 4 and 5, guess what it is, 4th grade? It's 20. Right? 4 times what? Equals 20, right? 5 times what? So this is 4 and 5, so this is 5. Right? So 3 times 4 is 12. 3 times 5 is 15. Okay? So, can I change my tape diagram into that? Absolutely I could, right? Sometimes that makes it a little harder. So, I could also do an area model, is another way to do this one. So if I had, here's my box, right? I had it in 4s, right? And there's 3/4, right? Now, I'm going to take that 4ths and I multiply it. If I get that 20, I would have to put it into 5s, right? So 1, 2, 3, 1, 2, 3, 4, 5. So now, that 3/4 just became 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 20ths. Oh, does that match up there? Sorry, 4th grade. Does that match up there? Absolutely, that matches up there. So I know, and then I could also do the area model. Then, so 5ths, 1, 2, 3, 1, 2, 3, 4, 5, right? Okay, and then I'd color in 3, and then I would do, this is 3/5, and if I am going to take it into 20, right, it's 4 times 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, 12 20ths. So which is greater, 15 20ths or 12 20ths? If you said 15 20ths, you're right. So 15 20ths is greater than 12 20ths. So I know that 4 and 3/4 is greater than 4 and 3/5, or that original fraction of 23/5. Okay. We're going to keep going, 4th grade. Ooh, I like it. Whew, they gave me a normal one. All right. I notice that I have 2 mixed fractions. This is easy. So I know that the whole number is the same. So I'm going to focus on that fraction. Okay, I'm going to focus on this fraction. Okay. I could do a number line, or I could do an area model, or I could do tape diagrams. It's up to you. I think for me, I'm just going to do the area model again. I kind of like it. So I've got 1, 2, 3, right? So I'm going to do 2/3. 1, 2. There's 2/3, right? And then this one is 3/5. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4, 5. Right? There's 3/5. 1, 2, 3. Right? Well, what is the common factor between 3 and 5 in that denominator? It's 15. Okay, so 3 times what would give me 15? Oh, it's 5 times. So 1, 2, 3, 4, 5. Okay, right? Equals 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 15ths. So 2/3 is 10 15ths. Okay. This one, if I did 5, I would have to multiply it by 3 to get 15. Right? So I can get 15. So I'm going to go 1, 2, 3. Right? And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 15ths. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 15ths. So 9 15ths. Which is greater, 10 15ths or 9 15ths? If you said 10 15ths, you're right. So 2 and 2/3 is greater than 2 and 3/5. All right, let's do our next one. Oh man, I got a mixed fraction and a fraction. So let's see if we can do it. So this one, I'm going to change this one into a mixed fraction to make it a little easier. I know that 5 can go into 8, right? So 5/5, there's 1. 5/5, there's 10. 5/5, that's 15. I can't do another one. So 15 plus what gives me 18? 3/5, right? So I've got 5, 10, 15, 16, 17, 18. 18/5. Ooh, how many holes do I have? I have 3. So I have 3 and 3/5, right? Because there's my 3 and my 3/5 is what's left over. So that fraction became 3 and 3/15. Now I can compare them. The whole number is the same, so now I'm going to compare the 7/10 and the 3/5. Okay. Now, I could use an area model. Okay. I could use a tape diagram. I could use a number line. It's up to you. I think this time I'm going to use, I'm just going to show, not an area model, a tape diagram, sorry. So I'm going to show 3/5, right? 1, 2, 3, 4, 5. And I'm looking down here, I'm see that has 10 and that has 5. And I know what they have in common is 10. So if I start with a 5, I think that'll be pretty easy because all I'd have to do, so right now here's 3/5, right? Okay. If I times those all by 2, right? Times it by 2, right? I'm going to get 10. So I'm going to break each of those down into 2s. Ooh. So I have 10 now, and then 3 times 2 would be 6. So let's see. 1, 2, 3, 4, 5, 6. Oh yeah, 6/10. So 4th grade, this one is 6/10. This one is 7/10. Now I have that common denominator. What's greater? The 7/10. So 3 7/10 is greater than 18/5 or 3 3/5. All right. So remember, 4th grade, you are going to be finding that common numerator and denominator, looking at those benchmark fractions using different models, either the tape diagrams, the area models, or a number line to compare fractions, telling whether they're greater than, less than, or equal to. Good luck today.